All right, in this explainer, we're going to build a smarter AI. We're going to move way beyond the basics to put together a production-ready system that doesn't just find information, but actually understands its context. Let's dive in.
So let's kick things off with a question I think we've all asked ourselves. Why do our AI assistants sometimes feel, well, a little clueless? You ask what seems like a simple question, and you get an answer that's technically right, maybe, but totally misses what you were actually asking. You know the problem? Almost every single time comes down to one critical thing: a lack of context.
So here's our game plan. We're going to start by really digging into the problem with current AI search, then we'll uncover the secret sauce that fixes it. From there, we'll actually build our advanced system, piece by piece. We'll even give it a few superpowers, before looking at the whole pipeline, and of course, the most important part, why any of this really matters.
Okay, first up, the RAG problem. See, before we can build something better, we've got to understand what we're fixing. Let's take a look at why today's smarter search often just isn't smart enough.
You know, the technology behind most of the AI search you see today is called Retrieval Augmented Generation, or just RAG for short. Honestly, the best way to think about it is like giving an AI an open book exam. Before it tries to answer your question, it gets to look up the relevant facts from a knowledge base. And that's great. It makes the answers way more factual. But it's definitely got some flaws.
So why does this basic RAG so often fall flat? Well, for one, it might pull up totally irrelevant results because it just doesn't get the nuance of your question. But a huge problem is that it splits documents into these little chunks, and if that split happens right in the middle of a sentence, all the meaning is just gone. It basically treats every little piece of information like it's on an island, completely cut off from the bigger picture.
And that brings us perfectly to our second section, and really the core idea of this entire system: context. This right here is the secret sauce. This is how we teach our AI to finally see the forest for the trees.
And here it is. This is the big aha moment. The solution is to use another AI to write a short, simple context for each chunk of text, explaining where it fits into the original document. So instead of just a raw, random snippet, the search system now gets a little summary of what that snippet is all about and where it came from. It's so simple but so powerful.
And this slide just illustrates the difference perfectly. On the left, you've got the raw chunk. It's a fact, sure, but it's just floating in a void. Now look at the right, the contextualized version. See that little sentence at the beginning? This chunk, from a document on AI history, explains the origin of the transformer model. All of a sudden, this chunk isn't just a random fact anymore. It has a purpose, a location, a meaning, and that makes it infinitely more searchable.
So for section 3, we're going to build our foundation. Now that we have this context-rich data, we need a really powerful engine to search through it. And for that, we're going to build a hybrid engine that combines the best of two very different search methods.
I love this analogy. Think of it like having two detectives on a case. First, you've got BM25 Search. This is your detail-oriented detective, absolutely brilliant at finding exact keywords, specific names, acronyms. Then you have Vector Search. This is your conceptual detective, the one who understands the underlying meaning and relationships in your question, even if you don't use the exact right words. By combining them in a tool like Elasticsearch, we get this amazing hybrid search that is both incredibly precise and super intuitive.
So here's how we actually get our data ready. First, smart chunking. We split the documents, but we do it carefully, at sentence boundaries, so we don't break them. Second, we generate that all-important context for every single chunk. Third, we create embeddings, which is just a fancy way of saying we convert these contextualized chunks into numbers or vectors that an AI can understand. And finally, we load all of this into Elasticsearch, which will be our hybrid search database.
Okay, our engine is built, it's solid. Now for the really fun part. We're going to add some superpowers. These two features, re-ranking and web search fallback, are what take this system from a cool project to something that's truly production-ready and incredibly robust.
Our first superpower is Cohere re-ranking. The best way to think of this is like a quality control expert. So after our hybrid search finds, say, the top 20 potential results, this specialized AI model comes in and takes a second look. It reevaluates all of them against the original question and picks only the absolute best, most relevant chunks to use for the final answer. It's a seriously powerful filter for accuracy.
Superpower number 2 is a total game changer: web search grounding. So what happens if somebody asks the AI something that just isn't in its knowledge base? Well, instead of just giving up and saying, "I don't know," it now has a safety net. It can automatically go out and search the web to ground its answer in new, up-to-date information. It's effectively expanding its own knowledge before it responds to you.
So we've built all the individual pieces. In our fifth section, let's put it all together. Let's see the full pipeline in action and trace a question from the moment it's asked to the final answer.
And here it is, the complete flow. A user asks a question. First, our hybrid search engine instantly pulls the top 20 possibilities. Second, Cohere re-ranks swoops in and narrows that down to the best 5. Third, the system does a quick confidence check. If it's not very confident, it triggers that web search fallback to get more info. And finally, armed with the best possible context, it generates a precise, well-sourced answer.
And that brings us to our final and maybe most important section, why this matters. I mean, all these steps and clever techniques are cool, but what's the actual, measurable impact of building a system this way? Well, let's look at the numbers.
Check this out. Just by implementing that single core idea, just adding a simple contextual sentence to each chunk before searching, the accuracy of finding the right information improves by a staggering 49%. That means the system is almost 50% better at its job right from the very first step.
But it gets even better. When you add that Cohere re-ranking superpower on top of the contextual search, the total improvement in accuracy jumps to 67%. That really shows you the power of a multi-pass system. Find a broad set of results first, and then use a specialist to zero in on the absolute best ones.
So let's just quickly recap the key takeaways from all this. First and foremost, context is everything. That's the single biggest innovation here. Second, hybrid search is always going to be more robust than just relying on one method alone. Third, re-ranking is your best friend for quality control and makes sure only the best information gets through. And finally, that web grounding provides a crucial safety net that makes your system infinitely more capable.
And that really leaves us with the final thought. By combining all these techniques, we've basically designed an AI that can not only find what you're looking for with incredible accuracy, but can also expand its own knowledge whenever it runs into something new. So I'll just leave you with this question. What could you build if your AI could never say, "I don't know" again?